Alright, hi everyone. This is the third and last example of chapter 9.2. It is question 203. Let's read the question. Question 203. Find the maximum velocity of photoelectron ejected by a 80 nanometer radiation. The work function of the photoelectrode is 4.73 electron volt. So let's write down the two pieces of information we're given. We're given lambda, so the wavelength of the photon. We are also given the work function. Now for this question, because we will need to find the final velocity of the electron, it is easier to convert in joule right away. So the work function in joule, we simply multiply 4.73 by the electron volt value. And it's often convenient to start by calculating the energy in each photon. This is equal to h multiplied by the frequency. We don't have the frequency, but the frequency is equal to c divided by lambda, and we get an energy in each photon of 2.485 multiplied by 10 to the power minus 18 joule. Now we again use the formula, the formula where the work function plus the maximum kinetic energy is equal to the energy in each photon. Now here I already switched the work function on the right side, so we're looking for the maximum kinetic energy here. We input these two values, so energy in each photon minus the energy needed to fight off the binding energy of the metal, and we get the maximum kinetic energy to be 1.7278 multiplied by 10 to the power minus 18 joule. Now, as before, the kinetic energy is equal to 1/2 mv squared. Now you may ask yourself, well, should we use the formula formulated by Einstein or simply the old kinetic energy formula? We're going to try with that one and see what kind of value we are getting. So here we got the value for the energy. The mass over here will be the mass of the electron. It is 9.11 multiplied by 10 to the power minus 31 kilogram. We input all these values and we get a speed of 1.95 multiplied by 10 to the power 6 meter per second. All right, so that's the official value. Now, often it is a good check, especially when we get value that get in the 10 to the power 6, 10 to the power 7, let's say, close to the speed of light, to get a sense of what the relativistic factor gamma would be equal to. Here, we will get the gamma to be 1.00002. So the velocity is not high enough to have any noticeable relativistic effect. So you can use directly the maximum kinetic energy. But if you were to calculate such a value and find out that the velocity will be, the gamma will be 1.1 and above, probably it is a good idea to use the relationship that Einstein developed instead. All right. But in this case, 1/2 mv squared does the job just well. All right, so we are done with chapter 9.2. In the next video, we're going to introduce chapter 9.4. All right, see you there.